Douglas and I have been working together for about 5 or 6 years and trying to pull people together from around the Chicago area mostly, around cities. And when I say people, I mean artists and architects, scientists from universities and national labs like Argonne. And early on, when we started these discussions, we would call 30 people into a room from around the Chicago area, and we would say, there's no agenda other than let's explore what might be possible when you bring a set of scientists and artists and architects together that they couldn't do individually. And one of the outgrowths of those discussions is this project, Array of Things. But I want to start with really, oh, there's a clicker. Talking about why. You've got this, so I'm not going to read this to you. Talking about why. I spent last year on weekly phone calls with a working group from the President's Council of Advisors on Science and Technology, or PCAST. And our charge from the National Science Officer, the President's Science Advisor, John Holdren, was to explore what the federal government could do, if anything, to help cities navigate the next 50 to 80 years and the challenges that they face. And we ended up talking about, capturing in a report, really 3 facets of cities. 1, the need for sustainable use of resources. 2, the mobility of people and ideas through cities. And 3, the enabling of individuals and groups in cities. In other words, are cities able to support the things that people want to do when they move to cities, have jobs, raise families, et cetera, and are cities working well for everyone in the city. So and of course you've probably heard all of the statistics about cities. 80% of patents, 80% of our GDP come from cities. And when I say cities, I don't just mean Chicago, New York, and LA, but places that have tens of thousands of people are included in that, cities. 70% of our greenhouse gas emissions come from cities or associated with cities, and about 70% of our energy use is in cities. So if we want to have an impact on society or on the climate or on resources, starting in cities is not a bad place to start. When we have engaged with architects and city planners around the world, what we've heard, Douglas and I have done a number of projects from city planners and architects of campuses or buildings, is that they're struggling with the way that architecture and city design were done in the 20th century and trying to apply that to the 21st century. And a lot of the rules of thumb from the 20th century don't really make sense for the 21st century.
Yeah, ideas of city planning that have been kind of popular for a long time were built on assumptions that really are proving to not be true anymore. They were built on assumptions of almost free energy or almost free labor. And so when you think about how we have to mobilize people and materials to make things now, there's a different condition going on. And so I think the necessity for understanding how that works, not only so that cities can be built, but then also become the livable environments we want, begin to necessitate the project that we're talking about today.
So let me start with some projects that we did with the City of Chicago when I first established the center, Urban Center for Computation and Data. The city of Chicago is one of the cities that has been most aggressive at publishing open data. And so we started looking at data with social scientists and economists from the University of Chicago, and we found this sort of striking about cities like Chicago, and these maps are about Chicago, but maps of other cities really look similar, where you have some parts of the city that just works better than other parts of the city. On the left, the life expectancy span there in Chicago is 14 years, depending on where you live. In Philadelphia, the span is 20 years between one neighborhood and another. 20-year difference in life expectancy depending on the neighborhood that you live in. Next over is asthma. And you can see more than 20% of kids with asthma have asthma in the red areas and less than 10% in the green areas. Urban heat island, the effect of weather on our just the temperature of the places that we live and work, unevenly spread across cities like Chicago. One that I find really striking is the one at the right. Ignoring the lake is gray. The rest of the part that's gray, those are parts of the city of Chicago where if you want to take public transit to this place here in the Loop, it'll take you at least 90 minutes. On the other hand, if you live in the green areas, it'll take you 30 minutes or less. And if you can sort of see, there's a pattern here of some parts of the city being red, other parts being green, and there's a pattern across these four. Now, when we thought about the Array of Things project, it really started with us looking at air quality and weather. If you look at the asthma rates, for example, parts of the city where we have these high asthma rates, we have no information about air quality. These are the EPA sensors in Chicago on the left, and those areas with the question mark, we have 0 sensors, and those are tens of square miles. So how do we address asthma in neighborhoods? Sorry, I hit a button accidentally. How do we address asthma in neighborhoods if we don't have neighborhood level data? And weather is the same way. As we started to engage scientists from universities around the country, really, about 30 universities started working with us about 3 years ago. We had workshops with different communities of scientists, social and economic scientists, transportation, engineering people, climate and environment scientists. We learned about what sort of things they would want to measure about cities on the left here. We also learned that there was a lot of research and policy that really needed more than just measuring something, really needed to look at the activity of the street, the flow of pedestrians, the flow of vehicles, or standing water on a street corner. And so we designed a device that would not just collect data and send it back to a server somewhere. That's actually pretty easy to do. We decided to design a device that actually has high performance computing inside the device. So we can use artificial intelligence on a street corner like that and start to support the kind of research that we need in order to make, for example, our streets safer. The Vision Zero, the focus cities there in the middle, Chicago is one of many cities that has a Vision Zero program, and the goal is to eliminate traffic-related fatalities by 2022. In Chicago, that's about 150 people a year. Our devices on the corner can pick up an accident that's not very difficult to do with computer vision and processing on the street corner. But they can also detect a near miss. Now, in any safety program, it's good if you know where the accidents are, but it's even better if you know where you almost had accidents. So these are the kind of things that caused us to say, let's build a device that actually has computing inside the device, so you can do computing right down on the street corner. And the reason you want to do it there instead of at a server is that sometimes you want an answer in real time, like should I change the lights or should I send a message to the autonomous vehicles that are running there 10 years from now. And you don't have time to wait for a server to respond because the event will already have passed. So what is it that we've built? These are the components we've built. And what we did was we started with, I think this is a pointer. So this board right up here, this board, and this board are designed by our team at Argonne. And by the way, all of these are built in the Chicago area. This board here allows us to inject right in here. These are a bunch of off-the-shelf sensors like temperature, pressure, humidity, or vibration.
Sound.
By the way, we also have a microphone in the Array of Things, so we'll be able to count those sirens as they go by too. So right in here we have these off-the-shelf sensors, and the process for adding a sensor there is about a 9-week process. So after we do a design, we hand it to the shop that makes the devices, and 9 weeks later we can hit print and have as many as we want. So the first thing we did was design a carrier, if you will, board, so that we could bring in new sensor technology. A couple of ones we're looking at, for example, are particle sensors that are the size of a button that cost $25, where the one that we have in our package, not shown here, is $400. So as sensors get cheaper, we can do what the EPA could not do, which is their sensors are $1 million stations. We can actually shrink that down to $1,000 or $2 with new sensor technology. This is a gas sensor board, so this gives us ozone and carbon monoxide and things like that, and that's a partnership with Intel. We have these cameras we'll talk about in a moment. One camera pointed straight up at the sky, the other one pointed down at the street intersection from about 20 feet up. And then if we wanted to just do this, just do sensors and send the data back to some server, that's a very straightforward thing to design. It's literally a weekend project to do something like that. Because these processors, that's a microprocessor, there's a $6 device. They are very, very reliable. They can run below freezing, at 160 degrees. You can put them in, this is the kind of thing that's in your car. But once you decide you're going to program the device, we're going to send programs to do artificial intelligence to the device, now you have to add these single board computers, which are, it's the same processor that's in a smartphone, and there's another one here. And those are not reliable. And when I say reliable, will they run for 2 years without having to intervene with a button or a software update? And so we had to build this device, this board here, to take the reliability of these kind of processors and manage these more complex devices. And that's what differentiates the array of things technology from all of the sensor networks that you see out there. So those are not able to do the artificial intelligence right inside.
So another word on that is I think a theme that you'll see in our presentation today is that the array of things really is a platform for urban science. And there's a lot of components in the collection of hardware that, as Charlie is saying, are relatively, they're affordable, they're reliable, and they're available. And I'm finding in architecture and design that students and young professionals are really experimenting with microcontroller technology, sensor technology, control technology as a normal part of the architectural propositional process. So I think that we just assume that buildings are made of architectural material, but they're also made of sensing material and data. And so it was an opportunity for design and the way that design is evolving to have an effect and really kind of become integrated into the project.
So this is what the packages look like. And if you walk over to State Street and walk up to Washington on the southeast corner and you look up, you'll find one of these. That's the closest one to this location here. And inside this part here that goes up against the pole is all the computing and the devices that we use, the logic for keeping that reliable. And then hanging inside this device here, these are a bunch of upside down bowls with holes cut in the middle, so you have a cavity on the inside. It allows air to flow through, it allows ambient light, but it doesn't let direct sunlight hit the boards or direct precipitation like rain or ice. And inside there we have this harness that's got our sensor board on the right, the Intel gas sensor on the left. This black thing is a microphone, and here's the camera pointed straight down. The other camera is at the top of this blue box right there. So that's the thing that we built. What we want to do this morning, by the way, is I've told you why we're building it and what we built. Douglas is going to now talk about the process for how this project is being carried out. And then I'll talk some more about the specifics of the project as we move forward.
I'm just going to use my fingers here. Yeah. So what I've really enjoyed about the process, really from the beginning until now, is how interdisciplinary the design team was. So not only is it a collection of scientists and engineers thinking about inventing and delivering this project, but there's been a really kind of a constant inclusion of architecture and design. We understand that the array of things is it's a civic technology, it's a community technology, it's a collection of computational devices that are going to be out there in public space, which is different than other kinds of technologies that are consumed in a different way or used in a different way. And so you might recognize this kind of very kind of agile design methodology where you have an idea, you define it, you test it, and then you define more features, and then you test it. And then at some point, you interact with the client or the receiver for their feedback. You incorporate those changes, and then you change and test again, and then you release. That's a kind of a common product development or design methodology. For the array of things, though, as much as possible, we wanted to see if we could have some sort of community engagement at as many levels of the product development as possible, because we knew that the array of things was going to unfold over a long period of time. Eventually, it was going to be positioned in a number of different neighborhoods, and the degree to which we could have kind of the Chicago constituency understand what it was, but then also be included in the development, we thought that that would make for a stronger project. So the kind of design activity managed by me and a few other people in the project really tried to organize that And we did that through just constant prototyping. There was always some parallel thread of making, interacting with the full team, resolving that as a small prototyping project, making it and testing it, so using the kind of available hardware and software technologies that an architect could experiment with for kind of data collecting device making, and making something, taking it right down to a city street, putting it on a pole, testing it to see if it would work, interview people as they walked by so they would begin to understand what it would mean to have a data collecting device that was kind of collecting information about ambient conditions in their public space. And so the more robust that got, the more visible that got, the more information that we could kind of generate and then feed back to the scientists and engineers on the project. But then also the more we could begin to develop a specific idea of community engagement. So the prototyping led to a fairly smooth handoff between the design development team and then eventually the initial production team. So we're working with a company, Product Development Technologies, in the Chicago area to make the first few, and we hope to have 50, roughly 50 up by Christmas, and then hundreds more by 2018. So because we had a pretty robust prototyping process, we had kind of vetted all the ideas of what it would mean to put this thing out into space. For example, we've partnered with the city of Chicago to use traffic infrastructure poles, like signal poles, as the site for these objects. Those poles are powered 24/7. It turns out that street lights are not, so we had to find city infrastructure that could provide power to these things all the time. But it was important that the CDOT crew could take our device and put it up into urban space pretty quickly. Hopefully we could get it up within 10 minutes. I don't know that we're quite there yet, but by the time we have a number of these things out there, we will.
Those guys, those electricians that you saw there, we've been working with them for 2 years. I've told people we've met with 7 layers of management in the city of Chicago about this project and gotten every layer very enthused. The design there, you can see in the top middle, Pete Beckman on the left is the chief computer scientist for the project working with me. And there are these flaps on the side that were meant to go around the pole. When we showed that to the electricians, they said, that's going to get in our way when we put those stainless steel straps on. So we changed that design. We worked with them on electrical safety as well. And as Doug said, the idea is once that wiring is done, it will take no more time or effort for the city to replace these as we make them better than it would take to hang a holiday wreath.
So, well, just a little bit more on CDOT. It turns out, as we were kind of talking with the CDOT crews, that there isn't a lot of facilitated management and kind of sensor-driven control of Chicago light infrastructure, less than I thought, right? And so they were actually quite excited that we might be installing a system that would help them kind of, perform and produce the kinds of things that they needed to do in their job. So right now, in most of the city, in order for a CDOT crew to understand that there is a street light out, they rely on the 311 reporting system. So somebody has to call in and say there's a street light out in my alley, and that message gets kind of moved through several layers of kind of information trading in the city. So, one of the first questions we had in one of the CDOT meetings was, will this thing know if the ambient light environment in an area has been affected, and could I use that to kind of help me optimize what I need to do in my CDOT work? And of course, it can. I'm just going to come back here. So this is, I don't know if I'm going to call it the final form, because the project has a very long kind of rollout, and so it's possible that we could explore different kinds of forms, but this is the one that we're going with for now, and Charlie described it a little bit before. So you can see that there's primarily 2 component systems. There's a control box that is attached to the pole, and then there is another form, the sensor cluster, as I call it, that kind of presents the sensors out into the world. If you know anything about weather system instrumentation, you'll kind of recognize that collection of kind of nested bowl-shaped forms, and it allows for air in and light in, but not direct air or direct light in. And it turns out that kind of referencing weather instrumentation iconography is something that has kind of helped the project be understood as an instrument collecting data that is of value, and less like, and I'm going to say this, an urban surveillance system. So this is something we can maybe get into when we get
the device
into,
right underneath on the pole.
yeah, get into Q&A. Yeah, so yeah, if you take a look at the camera system, that Darth Vader looking like black box down below the array of things node, we wanted the array of things node to be visible, more visible than most sensor instrumentation infrastructure that you see out there in the world. So there's no attempt to camouflage. In fact, we're kind of using colors and forms that might be more noticeable than other kinds of kind of street furniture. And we're doing that because we really want to kind of, prompt and interaction. So people notice it, talk about it, question it, what is that thing? And that provides the space for us to deliver even more information about the project and create a kind of a feedback that we think would be really useful in the participatory design of the system. So, we did a variety of kind of formal prototyping, and we ended with the one that we thought was, of course, high performing, but also kind of referenced the kind of instrumentation that we think people could recognize. So another element of trying to create a platform for kind of engagement of Chicago citizens is the work that we've been doing ongoing, really since the beginning of the project, to develop kind of educational and outreach systems for connecting with primarily kids in the Chicago public school system. So we've been running a number of activities, workshop activities and summer programs, or kind of augmented curriculum in computer science coursework in Chicago public high schools about embedded sensing. What does it mean to have a device that can be installed in a place and provide some sort of measured observation over time? What is that good for? What are the issues that are involved? How might that be kind of useful for placemaking and life making in a city? So one that we've run once, and we're going to run again in the spring, is a workshop at Lane Tech High School on the city's north side. So connected to their existing computer science curriculum, where we kind of reference the Array of Things project, and we've created a kind of multi-week workshop where we teach students how to make their own data collecting device with any number of available hardware and software platforms that are emerging now. And so, really interesting questions begin to emerge, and I think we can get at interesting issues through the making of a device in a way that would not be possible if we used a different kind of strategy. So when you kind of instruct, a kid in a high school to make a data collecting device about something that they're interested in, for example, some students at Lane Tech were really interested in the air quality in classroom spaces because there's a lot of construction happening right now. There's a lot of kind of additions and renovations happening in their high school. And they just thought that, when they go into one room, that the air just felt, different. And so a couple of groups made, air quality measuring sensors that they installed in a classroom, and they collected information about the change in air quality that they could then correlate back to when construction crews were working and when they weren't. And so when that is the foundation, kind of interesting conditions emerge. We can say, well, what is the phenomena that you're interested in? What kind of technical device would be the best thing to provide measured observation of that phenomena? And if you're making a data collecting device and you're putting it out into the school's public space, do you need to ask somebody? Do you need to ask permission to do that? If you think you do, who do you ask? Do you ask the principal? Do you ask the janitor? Do you ask the student body? Do you ask the teacher that might be in a classroom? Probably all of the above. And then when you're collecting information about a condition that everybody is participating in, right? So when people flow into a classroom, just by breathing, they're changing the quality of the air, so they're kind of adding to that condition. Do you need to provide a way for people to participate in that information that is collected later? And if you decide yes, how do you do that? How do you make it available? And so at some point, it became a really interesting project where students, started engaging the school newspaper and talking to the principal about the various things in the school that they might be able to learn more about and potentially improve if they had device systems like this. And I'm just going to turn it over to Charlie now. He's going to talk about how the project is going to roll out.
Earlier when I was talking about why, let me give some examples of why is the city of Chicago interested in this, and why are other cities, and why are scientists interested? What do we hope to get from these kind of measurements? I did talk a little bit about traffic safety and asthma, but if you look at this map here, these are the first 40 locations that are being rolled out in the next few weeks, and some of them are already up. And the way the 500 will be pushed out through the city is really going to look a lot like this, and that is that we have a specific question that we want to try to answer. In the Pilsen and McKinley Park neighborhoods here, these stars, there's a specific reason for putting those sensors in that place, and that is we have the Stevenson Expressway going right through those neighborhoods, a bunch of factories, and a history of bad air, a history of air quality that's worse than the neighborhoods around it. We have a partnership with the Instituto del Progreso Latino there, a charter high school where there's a focus in that high school on healthcare careers. And so that made sense to go there to look at, and it's also one of the places with high asthma rates. So that's an experiment about air quality and asthma, and what we hope to learn from this is not just about the end air quality measurements, but are we putting the nodes in the right place? Are we measuring the right things? Are they the right height on the poles, or do we need to put them lower or put multiple in? Then you see there's a T-shaped configuration along the lakefront and out, starting at Randolph and going out west. That's a set of scientists that are looking at the impact of the lake effect on air quality and weather. And then inside the loop, you can see sort of dual purpose of the east-west there, but then along State Street, that's where we're going to be using those sensors to perfect the flow of pedestrians and vehicle technologies and other activity technologies. For example, Portland's one of the cities we're talking with. In Portland, like in Chicago, they have a bike share program. And the city of Portland is concerned because their observation is that when people are riding a bike share bike, they are less likely to wear a helmet than if they're riding their own bike. Maybe they just didn't bring their helmet with them. So they're worried about the safety impact of that program. Well, with the artificial intelligence inside our devices, then we can write the software to not just count the bikes, but look for the private versus the very visible bike shares, and then look and see if the people have helmets on. So that's this in the loop here is where we'll start to support research in those areas there. And in each of these, we're looking for three things that come together, and it starts with some concern of a community group, or in the case of the loop, it was the Chicago Loop Alliance, something they were interested in learning or fixing or both about their neighborhood. And then we look for a science group or set of science groups who already have funding to look at that kind of an issue and would love to have Chicago as their test bed. Just yesterday, I talked to a team at University of Wisconsin that are doing air quality research, and they didn't know about the array of things or how they could get involved. And I said, well, join our team. We have 4 science teams that are driving the project, and you can help us select the next 100 or 200 locations so we can support that air quality research. And then the third thing we're looking for is policy, and that is there an alderman, or is there a city department head or agency head or commissioner that's interested, if they have insight into that concern, that is interested in doing something about it. When those three come together, and when we go into neighborhoods and have these community meetings, like you see on the right-hand side here, people get very interested in this project because it's something that's meant to help them in their neighborhood. All of the data that we collect is intended to go out openly and freely. Within a few minutes, the data will be sent out, and we're working on mechanisms that will enable us to let people reuse the data in various ways. The first is that we've built portals, if you will, web portals, that allow different target audiences to look at already open data, and these are being updated to include the sensor data. At the top left, you see a portal that we built mostly for policymakers, economists, social scientists, where they wanted to do a set of research activities, but there are all these open data portals, the city of Chicago, Cook County, state of Illinois, city of Milwaukee, et cetera, and there was no way for them to easily find data related to their question. So we built a portal here that said, just draw on a map and then tell us a range of dates, and we'll go find what data is available in open data portals, and we'll let you explore it, and then you can download it and do your research. The city of Chicago took that system that we built, and then they used the interfaces that we built for software, and they built their own portal down at the bottom. This is called OpenGrid, and it's at the website opengrid.io. That's the same data that we have in the upper left. It's our system in the back of it, but that's for a target audience of residents. So if a resident wants to know about 311 calls in their area or food safety inspections or what have you, they can go to OpenGrid. And then, as I mentioned, these programming interfaces to be able to get into the server, that allows people to write applications that would run on, say, a mobile device or alternate portals. Microsoft, one of our partners, is building a portal that will not be target audience residents or scientists, but high school students and faculty members.
So we'll
and they'll use that.
Yeah, we'll pilot that in the Lane Tech program that we're doing in the spring.
Yeah, so we'll pull the Lane Tech curriculum in and then give the kids tools that they can look at this array of things data and find something interesting of interest to them in the science area. So let me close by saying where we're going. We were surprised. When we started this project, we thought, this is great, we'll put 500 sensors throughout the city of Chicago, and maybe a few other cities might put some in. And so we set up the whole system to build these in the Chicago area, to prototype them at Argonne. And then we started getting phone calls from universities and cities around the world, 60 of them to date, and this is in the last 16 months or so, wanting to do pilot projects. So we've had to really sort of pivot the project and think about how do we design a system that can have tens of thousands of nodes around the world and that can be cost effectively managed. So we did some things in the software, we did some things in the hardware, and we're going to start these pilot programs in February or so with the red cities on there, the big red dots. So in the US, it's Seattle, Portland, Denver, Chattanooga, and Washington, D.C. In Europe, it's Bristol and Newcastle in the UK, and then we're also doing Delhi. The University of Chicago Delhi Center is our partner there, and Hong Kong. And then I was in Paris 2 weeks ago, week and a half ago, and they want to do a pilot in Paris as well. These will start at 10 nodes a piece, and then we'll move from there. Also now turned red is Dubai, and they want to do, for their Sustainability Day in February, they want to show off the array of things. And we heard about Hyderabad, India, and because we've read in the newspaper they were going to do array of things, because the state CIO was over there and said you should do array of things. So they committed to it in the newspaper, and we're still waiting for them to call us, but maybe we'll give them a call.
It turns out that there's a lot more organizations that want to ask questions with devices like this than device makers. I think that this is just the tip of the iceberg, actually.
Yeah, so where we're headed from here, I don't know if this is the last slide or not.
It is. Yeah.
Is it?
Yeah.
Where we're headed from here is, we were planning to do 10 of these per week, and so we've set up a production process and supply chain to do that here in Chicago, or in the Chicago area, with 4 companies we've been working with. Now we're starting to evaluate companies around the Chicago area who might be able to make these at quantities of 50 or 100 per week, because as this map sort of builds out, we're going to need to make a lot of these devices. So it looks like we're also going to spin out a company from the University of Chicago just to manage all of these projects here. And there's some opportunities that we feel are important here from a science point of view, not from a point of view of wanting to sell lots of gadgets. So most important one is that, as we started talking about, cities are making investments all around the world, or interventions to try to do traffic safety or air quality or other things. And they don't have the tools to measure the effectiveness of those investments. And they don't have the tools to say, well, what Atlanta did might work in Chicago, so let's try that. Or what Chicago did with food safety inspections might work in New Orleans, so let's try that. So having an infrastructure where there's a common way of measuring things is, of course, important. As important is that the real differentiator between the blue sites and the red sites is the red sites have a university partner. We're not going directly and partnering with the city of Seattle, we're partnering with the University of Washington. And we're using this platform to enable them to work with their local city. So as we build this out, we're also building out a consortium of university and national laboratory partners that will continue to make this platform more powerful in several ways. One, just to analyze the data. The other is to build applications on the platform. To propose or bring new sensors, we've got a roadmap of about 2 years looking at commercial and research groups that have new sensors that will drive the price of the sensors down by factors of 20 to 100. New materials like carbon nanotube technology at Argonne National Laboratory. There's a particle sensor that a group at UI Chicago is developing.
And microfluidics, yeah.
Yeah, with microfluidics. And then the computer vision expertise, or just broadly artificial intelligence, we're building this worldwide network of scientists who do artificial intelligence and saying, hey, I gave a talk at Carnegie Mellon a couple months ago, and it was 100 computer engineering and computer science students, and I said, you should be thinking about what you would want to do with 1,000 cameras in a city like Chicago, 500 of them pointed at the sky, 500 of them pointed down at the road surface, and what kind of innovation could you do in artificial intelligence beyond just looking for a near miss or counting bikes and helmets and standing flooding. So as you can tell, we're excited about where this project is going. It's a bit of a tiger by the tail, and we wanted to make sure we have time for questions. So we'll turn it over to questions now in the back of the room.